We're on to section B already. Right, what's simple harmonic motion? We've said this a few times. Simple harmonic motion, what are the key points to get the definition right in the exam? Firstly, you want the acceleration to be proportional to the displacement, or the distance, rather. The magnitude of the acceleration to be proportional to the distance. What else? You also wanted the acceleration acting to one fixed point. Yeah?
Acceleration or force?
Both are fine. And also, you want the acceleration to act opposite to the velocity, or something equivalent. So the idea is you have a fixed point, and as the distance increases, the acceleration increases, and if its velocity is to the right, the acceleration will be to the left. This is the kind of key ideas. Right, what's the next part? Is it a little graph? For total energy.
Yes.
Right, so do you remember how the energy graph looks for simple harmonic motion? What you've got here is, this is displacement x in meters, and this is energy here in joules, and this here is the amplitude A and minus A, and the kinetic energy starts at rest, the potential energy goes down, and the kinetic energy goes up. It'll catch up. Just the weight. Come on. Come on. Yeah, there you go. Right, and the equilibrium position is here. Equilibrium. And total energy we need as well.
So basically the energy does not go.
Rock and roll. Next one's just a pendulum, isn't it?
Yes.
2 seconds, amplitude 4 centimeters. Amplitude 0.04, time is 2 seconds. What's the first question? What's it?
Find the length of pendulum.
So I need to use this formula, correct?
Yes.
So I have t squared over 4 pi squared times g is equal to the length. 2 squared times 9.81 divided by 4 divided by pi squared. Is the length nearly a meter?
0.9. Yes.
Okay, what's the next part? Velocity when? Maximum?
Not omega.
Yeah, a omega, yeah, which is a 2 pi over t 0.1257 meters per second. What's next? Let me guess. Maximum acceleration? Did I guess right?
No.
No.
Yes. No.
Which?
At which position will the motion of the maximum velocity occur?
At equilibrium, which is the lowest point. What's next?
Determine the maximum acceleration.
Oh yeah. So A equals A omega squared. which is A 2 pi over T squared. Is it 0.3948 meters per second squared?
Yes.
Where will this, is the next one, where will this occur?
Yes.
At the end points, which is the highest. Right, what's next? Or is that the end of the B part? So on to the C part now. 300 grams is hung and extends by 0.15 and it's pulled down by a further 0.10. Okay, so when it's at rest, what's the mass? 0.3 kilograms will cause an extension of 0.15 meters. Then it's pulled down a further 10. And then it'll start to bob up and down. What's the time? Alright, so again, that's easy. T is 2 pi root m over k, correct?
Mm-hmm.
Now the only problem here is what?
We
Don't know the k, but that's no big deal because in the beginning, when it wasn't moving, it was at rest, and the up force, which was from Hooke's law, k delta x, should equal the down force, which is mg. So you know that delta x, which is 0.15 times k, should equal 0.3 times 9.81. So in this way you can get the k. Did he actually ask for the k as a later part? No. Okay. But we need it anyways. 19.62 newtons per meter. Pop that in there and I can get the T. Is the time 0.7769 seconds?
Yes.
Okay.
Yes.
Yeah. What's next now?
Find the position
After 2 seconds. So it starts here, I assume, and it's heading up. What do I need here? Cos or sine?
sound.
Cos. And we'll call down positive and up negative, okay? From the equilibrium position. The A is 0.1 and the omega is 2 pi over T, which I know, and because it starts at the extreme points. What's the small t? 2. So this will be 0.1 cos of 16.17 that is minus 0.0893. So that means it will be 8 it will be 89.3 millimeters above the equilibrium. What did he say?
This occurs at the amplitude of motion.
No, that's the wrong answer to the wrong question.
What did you say?
What's the position after 2 seconds?
Oh, 0.04.
0.04?
Yes.
That's his answer.
Plus or minus.
Wait, whoa. What?
Sorry, I'm reading the wrong thing.
C part 2.
So sorry. Shoot. Minus 0.092.
92. Yeah, okay. Right. And then, will it be moving up or down? Well, how could I work that out? Well, that's not too bad. I could just calculate what? What could I do to work out if it's going up or down? I can just calculate the V. V will equal A omega minus A omega sine omega t. So that will equal, and in fact, I only care about what this is because I only care if it's positive or negative. So sine,
So there's minus something.
yeah, no, I'll have to change it. Sine 16.17. So this is a negative, this is a positive, and this is a negative. So the total will be
Positive.
positive, which means it's heading down. What's his answer?
Number,
Literally the last answer in part 1, B1.
it's moving down.
Yep. Not a bad mechanics question. You know, the pendulum questions he writes are usually good questions. His pendulum spring questions. Yeah.